Howdy there, Internet students. This is the third part of Lesson 6.1c. We're going to stretch ourselves a little and use the Pythagorean theorem to help us solve some problems here. Go ahead and do the first one there, number 271. You should be able to handle that. That's just a straight up Pythagorean theorem problem. And actually do 273 also, and you can check back and see if you work. 272 is just a rectangle. Just know that this x right here is x, and 9 would be the two parts that make up the right angle there. So, and 15 is the hypotenuse on that one. Go ahead and do the first three problems. All right, here's your answers for those. And check them off. Okay, now they're going to get a little bit harder. Remember that an isosceles triangle means that that has two equal sides, and that the altitude then would split the bottom in half. So that's your hint on doing that one. Go ahead and solve that. Okay, the second one is going to take 2 steps to get the answer. X is the diagonal in the box. So first of all, we're going to do, we're going to find this length here, and then we know that this length is 18 because it'd be the same as the height of the box. But to find this length at the bottom there, I'll draw it in red. That's actually, the corners are right angles, even though they three-dimensionally don't look like it. And this is 30. So to find this missing, let's call it y for now. We're going to do y squared equals 24 squared plus 30 squared to find y. And once you find y, then you can use this 18 here to find the missing number x. Go ahead and give that a try. All right, if you got 42.4, somewhere around there, you did that one right. Okay, now this on 276, this is on a coordinate grid, so you have to know that 40 is actually the y value. That is the distance from the x-axis up to that point. So this would be 40, and so we're actually looking for x on that one. So see if you can find it. Do you see the right triangle there? All right, give that a shot. All right, that's what I got on that one. On this one, I'll go through the first number 281 with you, and then you can try your luck at 282, see if you can figure it out. But we have a lot of different numbers here, but basically the idea is we have some similar triangles. If you look closely at this triangle, that's one of the triangles. So what I'm going to do for the base of that one is add the 60 and the 30. So that's 90 squared plus 48 squared, and that's going to equal x squared. So that's how I'll find x. And then to get y, I have this distance here is 34, and this distance here is 30. And y is one of the legs, so I would have to do like 30 squared plus y squared equals 34 squared to get that one. I'll let you finish that up. All right, this next one, 282, that's going to be a little trickier to get our numbers. We can start by getting this length here from C to B. So I'm just going to label that C right now, small c. Notice that we have the 10 is the hypotenuse of that triangle, 6 is one of the legs, c is the other. So I can do c squared plus 6 squared equals 10 squared. And so go ahead and find. You should have got 8 for that. And now that I have that, I can use that 8. I'm searching for y here. And what I need to do is notice that I have some similar triangles here. This x over this y is the same as 6 over 8 on all these triangles, or 3/4. In other words, the legs are always in the ratio of 3 to 4. So you can use that to help you find, now that we know that C is 8, and all right, so here, let's use these two. So if I use from this triangle the x and the 6, that ratio needs to be the same as the short side on this big triangle, following me, which is 6 over the long side, which is 10. So to find x, I'm going to do cross multiply and divide. So 6 times 6 is 36, divided by 10 is 3.6. And that goes there where the x is. That's 3.6. And I'll let you finish it up and find y. You should have got 4.8 for that one. All right, on the last one, we got a railroad. Last page here, we got a railroad line problem. So metal expands and contracts as it heats up, and what we have here is that the it can for each mile of track it can expand up to 1 foot. So this diagram was made to see how high it would go if the ends were stuck. So basically, this is a right triangle here. So we're wondering how high that would lift up. So use Pythagorean's theorem to find that. All right, here's what I got for that. And on the last one, we've already done one like this, a box problem, but you want to know what the distance is diagonally across the box. So start by find this red line length by using the 12 and the 15. And then once you know that, use that length and the 9 to get this triangle length. All right? I'm going to leave this last problem for you to see if you could figure it out. If you do, message me and I'll let you know if you got it right. Other than that, we'll talk to you soon. Good luck with that last problem.